Hello world, welcome back to another tutorial. Today we are going to be making our chest look a lot better. Oops, wrong chest video. Of course, that's not the chest I'm talking about. I am talking about this chest. The chest we were working on in the submeshes tutorial. Basically, we added this chest and there was nothing on it. It's just a gray chest, pretty boring, same material all over the entire thing. And in the last tutorial, we talked about the .mtl file. What we're gonna be doing is we're going to be applying what we learned in the .mtl file video into the submeshes video. Different submeshes are gonna have different materials. From the .mtl file, we're gonna merge it with the .obj file. Lot to talk about, let's get into it. So back in our engine, we have this pretty boring chest with no textures and no materials applied to it really. Let's go and fix that. I'm gonna jump into chest.obj and let's look around just for a millisecond. So the material library that this chest needs in the obj file is the chest.mtl file. So it's saying, I need the material library for chest.mtl. And this chest.mtl should have a couple of materials. If I do a Command-Shift-F on use material, jump to the first use material. First material it needs is metal material, and that's gonna be assigned to these primitives. If I jump ahead, it also needs a wood material. Where in the world could I find an MTL file with these values? I'm just gonna go ahead and drag them in. That's what I'm gonna do, because we already have this. When you use Blender or something, you can export with the material objects. And now you see there's 3 extra files. We have the chest metal base color PNG, and we have the wood base color PNG. Now I'm gonna show you the metal, because this is going to be the metal parts of the chest. This is going to be the wood parts of the chest. And this is the chest MTL file itself. Now, I'm not gonna cover all these properties in this tutorial. I already covered that in the last tutorial. Go watch that. It's way more informative. I don't have time for this. Really simply though, this is the ambient, diffuse, specular values. There's gonna be like the material. And then these are going to be the maps or the texture values that are assigned to each material. And as you can see, the map KD contains this chest metal base color.png. And that's gonna be right here. I included that with the metal. And here's the wood for the wood material. But it's commented out, so we need to uncomment it. And ready to go. If you look down here, there was an error. This error says, unable to find MTL file, chest.mtl. And this is when I ran it without this material file existing, because it's already trying to look for a material file. And I'll show you exactly where that's occurring. So if we go into mesh library and we scroll down into the class mesh, if we look at the create mesh from model class, where we are saying let asset equal a new MDL asset with all these different values, this is where this error is occurring, because it's really trying to merge. It's saying you are an OBJ file, your chest OBJ. What material file do you need? Oh, chest MTL. I'm gonna load that too. Oh, you don't exist? Throw error. But yeah, this is where that's occurring. Now, since it's loading this material file, we have materials and textures available to us, but the textures haven't been fully loaded yet. So what we need to do is we need to call asset.loadTextures. You need to call this because it will cause a lot of headaches if you do not. So load textures, people. Let's scroll down and look at this little function now. Right now, we're currently creating this array of MTK mesh, which contains our vertex positioning data. And that's cool, but this MTK mesh array does not have anything to do with our material. What we need is an MDL mesh, not an MTK mesh, an MDL mesh, the model IO mesh. And we can load that very similarly. So I'm gonna do that real quick and I'll be right back. I told you it was similar. MDL meshes equals an empty MDL mesh array. And then I also added this little line of code that is basically this from loading the metal kit meshes, and now we're just loading model IO meshes into our MDL meshes. Now, one other thing to note is these two arrays are 1-to-1. So the value, the mesh at index 0 of this array is the same mesh as the value at index 0 of this array. This will contain those positioning datas. This will contain that material. So if I scroll down and look at this little for loop, I'll show you what I mean. Give me one second. So the couple of lines of code I just added are let MDL mesh equal MDL meshes at 0. These two are basically the same mesh. And then down here, I am now grabbing submesh at index I of our new MDL mesh. Now you need to add this information so it knows it's an MDL submesh. Pretty cool though. So now we have an MTK submesh and an MDL submesh. let's create our custom submesh with the new parameter also of MDL submesh. Now, of course, this is breaking because our initializer doesn't actually take in an MDL submesh. Let's go fix that. So if I scroll down here to our class submesh and look at that initializer where we're taking in the MTK submesh, I'm also going to add another parameter for the MDL submesh. And the project should build just fine now. Instead of processing the materials that are applied to these submeshes inside of the initializer, what I want to do is I want to create two functions. We want a function to load the textures and load the material for the submesh. So I'm going to create two functions. I'll be right back. Now that we have these two functions, create texture and create material, that is taking in a parameter of the MDL material, we can call it from the initializer. So above, I'll just say create texture with our MDL material, which comes from MDL submesh dot material. And we'll also call create material MDL submesh dot material. Now let's implement these functions. Let's start with create texture because that's a little bit more interesting than just materials. So let's go ahead and do create texture. In order for us to load textures from this material submesh, we actually need to add one more function. So I'm gonna go ahead and paste that right here and we're gonna look through it real quick. This is the texture function. We take in a MDL material semantic. Now, if you've never seen this before, it's okay. Basically, what an MDL material semantic is it's just the different values that exist in our MTL file. So if you see base color, it's going to be the color of a surface. And if I click on base color and scroll down to the bottom of base color, you'll see that it uses this with KD. So KD inside of our MTL file, that's the diffuse value. And then map KD, which is the diffuse texture. So base color is basically what we're going to use for the base color texture. And then, we have also specular exponent, all these different values. This is what the MDL material semantic is. I'll leave this link in the description. You guys go peruse that at your own leisure. But basically, we're going to take in which texture we want to grab. So in our case, this will be basically dot base texture because that's what we want. We're going to take in that material that we're passing down through create material. And then we're going to take in a texture origin. Probably just going to be bottom left, but we'll make it customizable for the future. And then what we're doing is we're creating a texture loader, just like we're doing over in our texture library. We're grabbing the material property with that semantic that we're passing in. So it's going to get that material property. And then it's going to get the texture that's applied using texture sampler value. And it's going to grab that texture. We have a couple options. We're generating mipmaps for this thing because we've covered mipmaps. And then we're also setting that origin. And then we're creating that actual MTL texture using textureloader.newTexture, and we're passing in these values. Now, this texture can be nil, and that's important. In the future, in a couple minutes, we're going to cover why being nil as a texture is okay. So down in create texture, we can now use this function. Now, it returns an MTL texture, which means we need to be able to set a texture value to this texture. So here at the top of the MTL submesh class, we're going to create a private var, and it's going to be base color texture. We also need, just while I'm up here, we also are going to need a material. So I'm just going to go private var material because we're going to need this in the future. And we'll just put that on hold for a second. What we really care about right now is that we have a base color texture inside of our submesh class. Inside of create texture, we can now say base color texture equals our new texture function. We're going to take in the material semantic of base color, like I said. The material, well, that's going to be the MDL material. And the origin is just going to be the bottom left for now. And there you have it. We've instantiated a new texture to be sent to the GPU. Now, we need to send this texture to the GPU. How do we send it to the GPU? Another function. Give me 1 second. I'm going to write that out right here, and I'll be right back. All right, so I've written a function called apply textures. It just kind of occurred to me that we didn't make these private, make create texture and create material private because we don't need to access those outside of this class. Apply textures is our new function where we take in a render command encoder because this is what we're going to want. This is where we're going to apply these textures to the GPU buffers. And then we're also going to take in a texture type The reason for this is because technically, yes, our mesh will load textures, but if we still want to apply from the top, from like, let's say the game object, a texture on top of the whole thing, we want the ability to do that. The first thing we do inside of this function is we set the fragment sampler state to this linear. We can make this customizable in the future, but for now we do need to set a sampler state somewhere. Then the next thing we do is this line 225. What we are doing here is we are creating a new texture, a new MTL texture. So if the custom one is none, meaning we didn't pass in our own custom texture that we want to use, let's use the base color texture, which is defined here at the top of the class. Else, if it is something other than none, that means we want to use a entity texture. So let's grab that from our entities textures library. And then we're simply just going to call render command encoder.set fragment texture at index 0. Now, this code here might look a little familiar, and that's because out inside of our game object class, if I just go here to game object and I scroll down, we are calling render command encoder.set fragment texture at index 0 right here. When we call mesh.draw primitives, this is where we are going to be using our new custom texture. So really, we don't actually need this line of code right there. And we also don't need this line of code because we're doing this down inside of the mesh. So I'm going to remove that as well. So I'm going to go down back into mesh library and we can continue. So we have this function, apply textures. We need to now just call it. So I'm going to scroll up here to the mesh class, go into draw primitives of the mesh class. And right here, when we're calling render command encoder.drawIndex primitives, we're iterating over our submesh. Let's just go submesh.apply textures. Let's pass in that render command encoder and a base color texture type. Let's make this dynamic. So here in the actual parameters to draw primitives, let's take in a custom, actually we don't need to call it custom, we'll just call it base color texture type. That'll be of type texture types, that's our own type. And I'll just set that to none by default so we don't need to pass a value yet. And then we'll just type in base color texture type. So when we call mesh.draw primitives, we can pass our own custom mesh, and we'll do that in a second. But now we're applying these textures. So now we are actually sending these textures to the GPU, but there's a couple of random bugs that we've kind of put into our code just from kind of examples. Let's go ahead and fix those. So let's jump into shaders, basic shaders.metal, scroll down to basic fragment shader, and look at some code. Right here, we are doing all this crazy logic. We don't really need all this information. What we can say instead of these if, else, let's just set this color equal to material.color to begin with. Let's just set it to material. And then we can use a nice little function where we say if, in our case, let's do not is null texture. And then we'll pass in our texture at texture 0. If that is not nil, then set that color equal to texture, whatever that color sample is. So now this code replaces all of this crazy code. And texture is a bad name, so I'm going to rename this to base color texture. Actually, I'll call it base color map, because really it's a map. And so I'll call it base color map. This will be base color map, and this will be base color map. However, we are now using things that we don't need. So in shared.metal, we can now remove down in the material struct these two values. Use material color, use texture, gone. Inside of our types, metal types, scroll down to material, and then you can also remove these two values as well. If you build, you'll notice that there's a bunch of different errors. So let's go replace those. So I'm just gonna click on each individual error. This took us to the game object class. If I scroll down, we can remove these two lines of code entirely, that one entirely. And then it looks like there's one more, use material color inside of instance game object. We can go and remove that as well. And it looks fine now. Another thing I kind of want to do just to kind of clean up some code is, well, first let's move this down with material. And texture type, remember I said we can pass our own custom texture from here. And so down in the doRender function, we can now say draw primitives with our own texture type. So I will say base color texture type, and I'll pass in our texture type. But texture type is a terrible name because we can have multiple textures. So let's refactor this, rename it to base color texture type. And boom, we have base color texture type now defined here at the top of the class. and it is initialized as .none by default, so it should be none when we pass it down through. So let's go ahead and press play and see what happens. And as you can see, we have a chest that has some textures. It has 2 textures applied. We have the metal texture and the wood texture. It looks great, but it's still using that basic material because this should be way more shiny than the wood. So what I'm gonna do is I'm gonna press stop and we're gonna go fix that. Let's start by going back into our chest.mtl file and fixing a couple of these values just to, give you guys an example of how cool this is. So the shininess right now for the metal is only 10. Let's set that to 100 because that makes a lot more sense if it's more shiny, because the wood's also 10. Let's make it more shiny. Let's also make the diffuse of this material red so that the metal edges will be a little bit more red, just so we know that it's working. And then the last thing we're gonna do is we're gonna set all of these specular values right here to be 1 because we want it to be really shiny. And that should do it for now inside of the MTL file for the material. So back in our submesh class, let's scroll down and implement this create material. I already have code written, so I'm just gonna go ahead and copy it and paste it in there, and we will talk all about it. What have I done here? I'm saying if let ambient equal MDL material dot property with, this is the MDL material semantic, emission is gonna be for ambient. We are setting the material.ambient equal to ambient. Remember, up at the top here, we've created a new material variable, and we're setting that material equal to this ambient value. And we're also doing the same for diffuse. Now, don't forget to use the correct float value. So right here, you can say float 4, float 3, float 2, whatever you need. In our case, ambient's gonna be float 3, and it's gonna read in that float 3 value. Shininess is gonna use the specular exponent because in the Phong shading formula, well, the shininess is the specular exponent, so we're gonna use that as well. And since we are calling create material already up here, that's already taken care of. However, we are not sending this meshes material to the GPU. So we need another function similar to apply textures. I'm gonna create that right now. Now, just like apply textures, we are taking in a render command encoder to apply this new material value to, and we are also taking in a custom material for the same reasons as this custom base texture type. We may want to change the material from the top level. So we want to provide that as an optional value. So basically this can be nil. And if this custom material is nil, let's just use the material we've defined at the top right here. Let's use that material. Else, let's use the custom material that we passed in that is not a nil value. Then we're simply gonna call render command encoder.set fragment bytes to this value. Let's go back up to our mesh class mesh, and go down to draw primitives. And underneath this apply textures, let's also call submesh.apply materials. Taking that render command encoder. Custom material is going to be, well, we need a custom material. Let's add that to draw primitives as well. So I will say custom, I'll just say material. That's fine. It will be of type material. It needs to be optional, and we'll set that equal to nil by default. Let's do this right here, material. That should work just fine. And when we press play, you'll see that we have that red tint that I was talking about on the metal aspects of the chest. And look at that there's a lot more shine on the metal parts than there is the wood, because the wood's not supposed to be shiny. What I do notice is it's kind of faded a little bit, and that's because we kind of have a bug with our ambient values. Ambient coloring is supposed to only apply to surfaces that aren't facing the light, and all these faces are facing the light, but we never took that into account, so it looks a little bit bland. So what we can do is we can go back out to sandbox scene, and we can say sun dot set light and ambient intensity set light ambient intensity to 0.04, something pretty low, and let's see what that looks like. And that looks a little bit better. As you can see, it's not all whited out, but look at that. Okay, cool. We're applying different materials to our box, but we don't really have a way of applying custom materials to it because we passed it in through our mesh library right here. So we are able to pass it in, but we never are. So let's go back out to our game object and change that. Where we will start is up here at the top. Let's make this, instead of instantiating it by default, let's go ahead and set this to nil. So this will be a material of type material question mark equals nil. Remember, if this is nil, it's going to use the meshes material. Else it will use this. Now let's scroll down and see all of these errors. We do not need any of these functions anymore. Any of them. So you can delete all of these right here. You can also delete set material color. Don't need that anymore. And we don't need this set material color anymore. All we need is a function, public func, called use material. And this will take in a material. And all we'll say here is material equals material. Now, anybody who's creating us, the instantiator of this game object class, can now pass in a material that they specifically want to use if they do not want to use the meshes MTL file material. Also, this set texture doesn't make any sense. Let's refactor it and rename it to set base color texture, or actually, let's say instead, use base texture, base color texture. That sounds good. And use material. Let's check that these two functions work. Oh, wait. Before we do that, look at this. Set fragment bytes to material. Do not need that anymore, so we can remove all of those. Something to look at right here is all we are doing is setting the model constants on the shader, which is cool because that's all we really care about. Now the mesh takes care of all of that other information. And we can pass in a material. So let's pass in our material value. Right now, since it's currently nil, it's just gonna surpass it and say, I don't know what the hell that is. I'm gonna use the meshes material. But if we do want to change this via use material, we can. So let's go test these out. Sandbox scene, chest. Let's start with the texture. Chest.use base color texture. Let's try that party pirate parrot. Ah, there's a build error, of course. Value of type sun has no member. Just delete that. We don't need that. Let's press play and see what happens. And of course, we are now using the party pirate parrot. See how it's using that same material though. The metal is shiny and this texture is not. It looks ridiculous. So let's not do that. Let's also apply a new material, our own custom material. So I've set the diffuse value to green. This is a nice green material. Let's press play and see if it looks like something out of Emerald City. Ah, chest to make the wizard proud. It's got that diffuse value that is green, and we can use materials and our own custom textures. Before we leave, I'm gonna make that chest not green, run it, and we can verify that everything looks spec-freaking-tacular. Do not forget to remove the red. So this chest needs to not be red. I hope you guys liked this episode. Please leave a thumbs up if you liked this episode or a comment. I know this was a little long. If you made it this far, leave a comment and tell me you made it this far because that's impressive. But yeah, I made it a little bit long because I wanted to get through these different things. I could have made this 2 episodes. Nah, there's other stuff I want to do. So I hope you guys liked it. See you next time.